You are welcome to today's meeting. At our last meeting, we talked about the topic called indices. We look at the basic laws of indices, then we move on to a simplification of indices. And finally, we landed on how to find or solve problems involving indices. Today, we are moving on to another topic called logarithm, or simply called log. So by the end of today's meeting, we should be able to achieve some objectives. And these are, we should be able to state and apply the basic laws of logarithms. Then we must also be able to simplify expression involving log and also solving problems involving log. So these are the three objectives that we should be able to achieve at the end of the session. So let's move on to logarithm. Derivatives for indices or exponential equation is logarithms, and we simply call it log. So assuming you have the log of a number x to the base a, is expressed as log base a of the number x. Log base a of the number x. So now if we have log base a of the number x equal to y, then we can now solve for the variable x by removing the base or sending the base from the left side to the right hand side. Now the base is assuming the base, or let's take that the base is carrying the variable x. So when it crosses equal sign to the right hand side, it will also carry anything which is there. So here we have y here. So when the base a is moved to the right hand side, it will be a power that y. Now in case, take it that if you take the log of, we have a power x equal to y, something like that. So whenever a is being removed from here to the right hand side, it will also come to carry the term or the variable here. And when a is taken away, the log goes away. So that's why you say x equal to a power y. X equal to a power y, as you see here. So now we were having a log here, log base a of x equal to y. Now after removing the base to the right hand side, now we move from the log to the indices. That's why we say that log is the reverse of indices, or indices is the reverse of logarithm. So let's see examples here. Example 1. Find the values of the variables in each of the following equations. So we are having I as log base 2 of x equal to 3. I log base 10 of y equal to 2. And I log base 3 of 27 equal to n. So let's see the solutions. Log base 2 of x equal to 3. Now, if you want to find x, you have to remove the base 2 here to the right hand side to form the power, or to be the power of the 3. So therefore, we have x equal to 2 power 3. And 2 power 3 is the same as 8, which is the same as 2 times 2 times 2, 3 times. So to be 8. Now, log base 10 of y equal to 2. In the same manner, we cannot move, if we want to find the y, we can just move the 10, the base here to the right-hand side, to be the power of 2, or to the power of 2. So when y is being removed to the right-hand side, it becomes y equal to 10 power 2. And 10 power 2 equal to 100. 10 power 2 equal to 100. So it means y equal to 100. So when we put the 100 here, log base 10 of 100 equal to 2. You can check that. Log base 10 of 100 equal to 2. The third one, log base 3 of 27 equal to n. Log base 3 of 27 equal to n. So by sending this 3 here, it becomes 27 equal to 3 power n. Now we have moved on to the indices. Therefore, we must apply the indices law, which says if a power m equal to a power n, since the bases are the same, then the powers must also be the same. So we are having here power base 3 here. We are having here 27. So we can express 27 as 3 power something. And 27 is 3 power 3. Therefore, we can write 3 power 3 equal to 3 power n. So since the bases are the same in this law, then we can just equate the powers. Hence, 3 equal to n, or n equal to 3. So this is the law of indices. When the bases are the same, then the powers are the same. When the powers are the same, then the bases must also be the same. Okay, let's see another example. Evaluate the following. I, log base x of 4 equal to 2. I log base 27 of y equal to 1 over 3. So let's look at the solutions. Log base x of 4 equal to 2. Now by sending the base here, it becomes 4 equal to x squared. So we have moved away from log to indices. Therefore, now we look at this 4, we can write this in the exponent form as 2 power 2. 2 power 2. So we are having 4 equal to 2 power 2. Therefore, we have 2 power 2. So 2 power 2 equal to x squared. Therefore, now the bases are not the same. 2 and x are not the same, but the top, the exponents are the same. Hence, the base must also be the same. Therefore, we can say x is also equal to 2. So we have also applied the same law of indices. Now let's look at the next example. Log base 27 of y equal to 1 over 3. Now, if we push or we send 27 to the right hand side, it becomes y equal to 27 power 1/3. And 27 power 1/3 is the same as cubic root of 27. You know 1 over 3, power 1 over 3 is the third root. So therefore, you can write it as cubic root of 27 from the law of indices. Therefore, y is also equal to 3. You can check this one using your calculator. Cubic root of 27, and the answer is 3. Now we can equally also apply another law of indices. Y is equal to 27. Now we can express this 27 in the exponent form, which will be 3 power 3. Therefore, we are now going to have 3 power 3 or power 1/3. And the powers will multiply by themselves. Therefore, we have 3 cancel the 3 here, making 3 power 1. hence y equal to 3 power 1. So let's look at the third example. Evaluate the following. I log base 2 of 64, log base 125 of 5, log base 2 of x, 3x plus 5 equal to 4, and log base 8 of 3k minus 1 equal to 1. Or we have the fifth one, log base 5 into bracket, negative 10x plus 4 equal to 4. So let's see the solutions for that. I. Now here the log is not equated to anything, so you can equate it to any variable at all. So let's equate log base 2 of 64 to x. So we are now having log base 2 of 64 equal to x. Therefore, as usual, I cannot send the base to this side. It becomes 64 equal to 2 power x. And by expressing this one in the exponent form, we have 2 power 6 equal to 64. So therefore, we have 2 power 6 equal to 2 power x. Now this is law, the bases are the same. Therefore, the top must also be the same. Hence, x equal to 6. The same manner, let's equate log base 125 of 5 equal to y. It can be any variable at all. So let that one be y. Now if you send this 125, the base here to the right hand side, it becomes 5 equal to 125 power y. So we cannot express the 125 in the exponent form, which is 5 power 3. 5 power 3. So therefore we have 5 equal to 5 power 3y. And here the bases are the same. Therefore, but don't forget that this 5 is also power 1. So you can say that 5 power 1 equal to 5 power 3y. If a number has no power, it means it's base of power 1. So if this 5 has no power here, it means it's power 1. And by comparing the bases, you can say that y1 equal to 3y. Hence, solving this equation will give us y equal to 1 over 3. I hope you are all following. So let's go to the next example. So we have log base 2 of 3x plus 5 equal to 4. By sending the 2 to the right hand side, it becomes 2 power 4. So therefore, we have 3x plus 5 equal to 2 power 4. We are having a linear equation here. But 2 power 4 is 16. Therefore, we have 3x plus 5 equal to 16. Hence, by solving for x, we have x equal to 11 over 3. That 75 to the right hand side becomes minus 2, 16 minus 5 is 11. Now divide 2 by 3, we have 11 over 3. So you can try the examples IV and V. The examples IV and V. You try them on your own. Now let's move on to the laws of logarithms. The basic laws of logarithms. Law 1. You can call the multiplication law. The multiplication law. Log base A of mn. Log base A of m times n. So m and n are multiplying themselves, so they are products. So log base A of m times n. Now equal to log base A of m plus log base A of n. Now since the numbers are multiplying, as we all know, addition normally goes with multiplication. And they're all having the same base, so we have the common base. Hence, it's like we are not distributing this base to the m and n. So it becomes log base a of m plus log base a of n. So that's the log of a product of two or more numbers equal to the sum of the log of a common base of the individual numbers. So let's see this example. Log base 10 of 2 into bracket 5. Log base 10 of 2 into bracket 5. So 2 can be m and 5 may be n. So they have a common base. Therefore, we are not going to have log base 10 of 2 plus log base 10 of 5. And by using calculator, you can compute log base 10 of 2. And that will give us 0.3010. Plus log base 10 of 5 will also give us 0.6990. And when we add them, it will give us 1. So see, at the right hand side, if you multiply 2 by 5, that will also give us 10. So to me, at the left side, we have log base 10 of 10, and the answer is 1. So let's do the next one. So if you have log base 5 of 4 plus log base 5 of 3. Now this time, we are adding 2 logs to the common base or common base. So you can just factorize like we are now factoring the common base out. We have log base 5. And since the log are adding, you multiply the number. So that's why you can also make it log base 5 of 4 times 3, which is the same as log base 5 of 12. So you can take any side of it. You can go by this one. By using calculator, you can compute log base 5 of 4 plus log base 5 of 3. And the answer that you get here will be the same as log base 5 of 12. Good. Now let's move on to the next law. That's why it's also called the quotient or division law. Quotient or division law. If I have log base a of m divided by n, so m over n. As multiplication goes with addition, so the division also goes with subtraction. So if the numbers are dividing, then you subtract their log. So log base a of m over n equal to log base a of m minus log base a of n. Why? Because the numbers here are dividing. Division goes with subtraction. And division we call the quotient. So let's do examples. Log base 10 of 5 over 2 can be written as log base 10 of 5 minus log base 10 of 2. And log base 10 of 5 is 0.5990 minus log base 2, 0.3010. So by simplifying this, it will give us 0.2980. Now let's move on to log base 10 of 10 minus log base 10 of 8. Now you have the common base 10 here, so you cannot bring the log base 10 out. And since you are subtracting, then you must divide the number. So we become log base 10 of 10 over 8. And the answer will give us 0.0970. Let's move on to the third law, that's the power law. Power. Now if you have log base a of the number m raised to the power p, log base a of m power p. Now you're having the three steps: base, A, M, P. So one, step 2, step 3. When it happens in that way, we send the power in front of the log. So it becomes P log base A of M. P log base A of M. I hope you are following. When we have in the 3 steps, like log base A of a number power something, then the power, the exponent, should be sent to multiply by the log, or should be sent in front of the log. So log base A of M power P is the same as P log base A of M. Example, log base 5 of 5 power 3. Now the exponent is 3 here, so therefore let's bring it in front to become 3 log base 5 of 5. And the answer will be 3 times 1, which is 3. So if I have log base 6 of 36, since I can express the number in terms of the base, then I know 6 power 2 is the same as 36. So I can write it as log base 6 of 6 power 2 in the exponent form. So this 36 is the same as 6 power 2. So that I'll get the same thing at the base and then the number. So by applying the power of 1, 2, 3, now send the 2 in front of the log to become 2 log base 6 of 6. And the answer will be 2. Log base 3 of 3, log base 3 of 6 power 4. Now you have 1, 2, 3. So 4 should go in front. Now you're having 4 log base 3 of 6. You can finally find the answer here by using calculator. So that's the power law. The power law. Always send the power in front of the log. Let's move on to 4th law. Now we have even seen, or we have applied this property. Log base A of A equals 1. When the base of the log is the same as the number that we are taking the log, then the answer is automatically 1. So we apply this one here when we got to the point where we have log base 6 of 6. So log base 6 of 6 is 1. That's why we got the answer here to be 1. Now when you go to here, log base 5 of 5 is also 1. That's why you got this one to 1. You can try it on your calculator. So log base 10 of 10 is 1. Log base 7 of 7 is 1. Log base 20 of 20 is 1. And so on and so forth. So note, if you write a log without a base, then that log is assumed to be in base 10. So whenever I'm using base 10, I can choose not to bring the base. I'll just write the log of that number. So whenever I see a log without a base, then the base is what? 10. Then also we don't have the log of negative number or negative base. So log of negative number or negative base is undefined. So we can't take the log of negative number, or the base must always be positive. So let's look at these examples. Evaluate the following. I, log base 10 of 6 plus log base 10 of 8 minus log base 10 of 4. So we are now mixed up addition and subtraction. We have to apply the quotient and then the multiplication law of indices. I log base 5 of 125 minus 3 log base 2 of 16. Then you have I 2 log base 6 of 36 plus log base 10 of 1000 minus 5 log base 3 of 81 all over log base 2 of 64. Then we also have log base 10 of 5 over 8 plus log base 10 of 2 over 3 minus 2 log base 10 of 7 over 12. log base 10 of 5 over 8 plus log base 10 of 2 over 5 minus 2 log base 10 of 7 over 12. These are under example 1. Now, second example. Evaluate log base 10 of a power 3, b power 4, c all over d squared, where a equal to 3, b equal to 2, c equal to 5, and d equal to 4. So let's look at the solutions. I, log base 10 of 6 plus log base 10 of 8 minus log base 10 of 4. So by taking the 2 terms here, it's addition. Hence, we can multiply the numbers. So we have log base 10 of 6 times 8. Now minus log base 10 of 4. So we have applied the multiplication law. Now that we have the subtraction, we move forward to also do the division law, the quotient law. But before then, we simplify the side here. 6 times 8. So we got log base 10 of 48. Now minus log base 10 of 4. So here we have to apply the quotient law here. The 2 terms or the 2 numbers are subtraction. So therefore, we have to divide the numbers. And that will give us log base 10 of 48 over 4. So by dividing 48 by 4, we are not going to have log base 10 of 12. And by computing this one with your calculator, the answer will be 1.0792. 1.0792. You can try it. If you have a calculator, you can just move on to find the individual terms, log base 6, log base 8, log base 4, and then subtract. You're going to get the same answer. Log base 5 of 125 minus 3 log base 2 of 16. Now the bases are not the same, and for that matter, we cannot apply the laws that we have learned, law 1 and law 2. That's the multiplication law and division law. We can apply them here. So, but you can apply different law here. If you look at the base here, it's 5. We can express 125 as exponent 5 power something. When we go here, this is the 2, so we can express this number 2 as also 2 power something. So 125 is 5 power 3. Therefore, we are now having log base 5 of 5 power 3, with the same as log base 5 of 125. Minus 3 log base 2 of 2 power 4, with the same as log base 2 of 16. They applying the power law. So if we are going to apply the power law, we are having 1, 2, 3, so the 4 should go here, and when we can the 3 also should go in front here. So we are not going to have 3 log base 5 of 5 minus 3. Now 4 should also come in front, become 4 log base 2 of 2. So by multiply 3 and 4, that will give us 12. Therefore, we have 3 log base 5 of 5 minus 12 log base 2 of 2. Now we have just learned that log base A of A equal to 1. When the base of the log is the same as the number that we are taking the log, then the answer is automatically equal to 1. Hence, whenever you see log base 5 of 5, you put that 1 there, and log base 2 of 2. So that's what you see. We have 3 times 1 minus 12 times 1 equal to -9. So let's see another example. We are having 2 log bases of 36 plus log base of 1000 minus 5 log base 3 of 81 all over log base 2 of 64. Here again, the bases are not the same. So when the bases are not the same, we have to look out for the power law, or we have to look out for a case, or if you can express that number in the exponent form in order to get log base A of A. If so, then you move ahead. So looking at the first term, 2 log base 6 of 36, we can express 36 as 6 power 2. We can express 1000 as 10 power 3. We can express 81 as 3 power 4. Therefore, we can express them as 2 log base 6 of 6 power 2 plus log base 10 of 10 power 3 minus 5 log base 3 of 3 power 4 all over log base 2 of 2 power 6. So again, we cannot apply log base a of a equal to 1 to do our substitution. But before we have to apply the power law. So 1, 2, 3, the 2 must go in front here to multiply the coefficient here. So we have 2 into bracket 2 log base 6 of 6. 3 should also go here to be in front. We have 3 log base 10 of 10. 4 must also go in front to multiply the 5 here to get 4 minus 4, 5 log base 3 of, or it can be 5 into bracket 4 log base 3 of 3. The same thing. All over 6 log base 2 of 2. That's it. She also go in front here. Power law. Now we then move ahead to apply log base a of a property. So whenever you see the log with the same base as the number, then we get substitute 1 there. So we are having here, so we come here, we have this, so we have 4. Now log base of 6 is 1 plus 3 times 1 minus 20. 4 times 5 is 20 times 1 all over 6 times 1. And this will give us negative 13 over 6. So you can try the question 1 IV. You can try the question 1 IV. Now let's move straight to the question example 2, where we have log base 10 of a cube, b power 4, c all over d squared. Then we can use the first and the second property, multiplication, and then the quotient law to expand this as log base 10 of a power 3 plus log base 10 of b power 4 plus log base 10 of c. Now d squared is divided, so minus log base 10 of d squared. So by applying that law, we are now having a power law 1, 2, 3. So you cannot do whatever you have the 3 steps 1, 2, 3, and so on and so forth. So that will give us log base 10 of 3 power 3. Because we do our substitution, we know A, we know B, we know C, we know this. So we can do the substitution there before even apply the power law. Or we can even move straight without even apply that power law. So let's do our substitution. So log base A, now A is 3 here, B is 2 here. Now we have C, it's also 1, and we have D, it's also 4. So by substituting them into this expansion, this is what we're going to have. Here we can still do apply the power law, we can get move straight. We know 3 cube is the same as 27, therefore we have 10. Log base 10 of 27. 2 power 4 is also 16, so we can have log base 10 of 16. Now log base 10 of 1 minus 4 power 2 is also 16, so log base 10 of 16. By using your calculator to compute them, we are not going to have this. Hence, we have the answer as 1.4314. So you can use the calculator to do the computation. Good. Now let's move on to the last aspect of log, the equation involving logarithms. or we can call them logarithmic equations. Logarithmic equations. Now that we have to apply the property there, one of the most important property when solving equation involving logarithms. Now the property is saying that if log base a of x equal to log base a of y, since the log have the same base at both sides, log base a, therefore the numbers must also be the same. So if you are having log base a of x equal to log base a of y, then x must be equal to y. We saw the similar law at the indices. When we got to the point where we had if a power m equal to a power n, since the bases are the same, then the powers must also be the same. It's the similar law that we apply here. So log base a of x equal to log base a of 5, then x is also equal to y. The above rule is applied when both logarithms have the same base. Example, find x if log base 10 of 3x equal to log base 10 of 2x plus 1. Now with this we have log base 10. This side we have log base 10, so the two are the same. Then we can just equate the numbers 3x and the 2x plus 1. So we have 3x equal to 2x plus 1. And by solving this linear equation, we are not going to have x equal to 1. I hope you're all following. Let's move on to the next example, example 2. Find the values of x in the following equation. Find the values of x in the following equation. Log base 10 of x minus log base 10 of into bracket 3x plus 2 equal to 0. I log base 5 of into bracket 2x plus 4 plus log base 5 of 3 equal to log base 5 of into bracket 5x minus 4. Log base 3 of 3x minus 2 equal to log base 3 of x plus 3 plus log base 3 of 4. The last one IV, log base 6 of x plus log base 6 of 5 minus log base 6 of 3x equal to 0. Solutions. Log base 10 of x equal to log base 10 of 3x plus 2. Now we can send this one to the right hand side to get log base 10 of x equal to log base 10 of 3x plus 2, so that we can now apply the law. Since the bases are the same, then the numbers must also be the same. And for that matter, by equating the numbers, we have x here equal to 3x plus 2, this one. So by solving these equations, we have x equal to minus 1. In the same way, we can also apply the quotient law, since the laws are now, we have subtraction here. So we can divide the numbers. So here, if you want to apply that law, the quotient law here becomes log base 10 of x over 3x plus 2. We can apply that law to here. So that's what we have here, equal to 0. Now by sending the base to the right hand side as usual, we are not going to have x over 3x plus 2 equal to 10 power 0. And from the indices, any number raised to the power 0 is 1 apart from 0, so 10 power 0 is 1. That's what you see. So hence we have x over 3x plus 2 equal to 1. So by cross multiplying, we are now going to have x equal to 3x plus 2. Hence, x equal to minus 1. The same answer. Second example. Log base 5 of 2x plus 4 plus log base 5 of 3 equal to log base 5 of 5x minus 4. The law is applying when we have one term at the left side and then one term at the right side. So if you are having more than one, you have to simplify to make it 1. So by taking the left hand side, we are having log base 5 of 2x plus 4 plus log base 5. So the same base, hence we can apply the first law, that's the multiplication law. So by multiplying the number 2x plus 4 and 3. And that's what will give us log base 5 of 2x plus 4 times 3. Now equal to log base 5 of 5x minus 4. So the bases are now the same, hence we cannot equate the numbers. Before they can even expand it to get here, 6x plus 12 here. And now equate the numbers. So now 6x plus 12 equal to 5x minus 4. Therefore, x equal to negative 16. So at this point, you can try the I and IV. You have been given some examples, now some assignments here. You are having a 3 questions to be solved and submit it at our next meeting. You can send it to the email. So we have an assignment 1, evaluate the following. We have all this I. Now we have this one also, that, and we have indices question also here. So let's solve them and submit them. I hope everything is okay now. So we say thank you for coming. Then let's meet next time. So hoping to see you. Thank you.